Okay, next up we have number 10, expected asset returns. And the arrow is pointing here, so we're going to start with the risky assets, B9. And the descriptions are very explicit, drag it down. Okay, next 11 is calculate these optimal risky portfolio weights. It's really what we're after here. And after this, we're going to calculate the opportunity set, the optimal portfolio, and we will graph our information. Okay, so notice that we now have points on the graph. Let's finish this up. Okay, so my optimal risky portfolio weights will be B62. Look how nicely this already highlights. B62 times matrix multiplication matrix inverse, our variance covariance matrix. Notice once I finished typing in the array, it already highlighted it. My matrix variance covariance matrix, I36 through I41, my 1 plus expected rate of return, minus I35, my risk-free rate, times J36 through J41. And the really nice thing is, because, why do I not have to drag this formula? Because I told it at the very end that I want this to be multiplied by a range of J36 through J41, and it went all the way down. We have some negative numbers here, that's for shorting. And let's do the next step. So we have the optimal risky portfolio, and this one should look familiar. So let's see where we start. What is it that I'm going to do? I'm going to do E107. So I'm going to open parentheses. Let's say 2 parentheses. Open 2 parentheses. I'm going to do E107. And for just a very short period of time, it's going to be blank. But it is our expected rate of return. Minus B8, which is our risk-free rate. My B8 risk-free rate, close parentheses, divided by 2 times B6. What is my B6? It's my risk aversion. This is my Y star. This is my optimal weight in the complete portfolio. My optimal risky portfolio weight in the complete portfolio, right? So I have my risky portfolio. I have calculated these optimal weights. Those optimal weights are calculated by maximizing the Sharpe ratio, or taking the first derivative of the Sharpe rate ratio. Now the optimal complete portfolio, the weight of the risky asset is calculating by maximizing the utility function. All right, so let's finish this up. I have my 2 times coefficient of risk aversion and times C107, which for the time being is also not here for now, but it is the standard deviation of the optimal portfolio. And we'll get there in a minute. We square this, close parentheses, and again, I'm going to multiply this by G70, G75, which is those cells. Why do I multiply it? Because in order to get my full weights in my complete portfolio, I can take the proportion of my risky portfolio within the complete portfolio and multiply it by weights within the risky portfolio. And for some reason, I think this is because of the formatting here, when I drag this down, when I highlight all the way here, I get an error message. You may see something else, and the simple thing is just to type it all the way in, and it's 75. Let's see, error message, but I believe this error message is because of the fact that there's zeros. We have division by 0, and once we fill out, it should work. E107 minus B8 divided by 2 times B6 times C107 squared. Looks good. Okay. Now my opportunity set curve. This is calculating the standard deviation within my opportunity set. So I'm using my eigenvectors and my expected return squared to figure out the standard deviation for this opportunity set. So open two parentheses, B58, and that is my A, times 1 plus B76 close squared minus 2 times B59, also locked, B59 times open parentheses 1 plus D76 close parentheses twice plus B60. Okay, do I have it correct? Just verifying my parentheses, B60, and then divided by, open parentheses again, $B, $58 times $B60. So notice these dollar signs, I'm logging these cells because I'm going to drag them down here. B58 times B60 minus B59 squared to 3 parentheses to the power of 1/2. This is standard deviation of this opportunity set. Okay, now if I locked everything correctly, B58 plus 126 squared minus 2 B59 times 1 plus B6. Okay, and now that I verified that all my cells are locked. Now I've got my standard deviations. Here I have D106. This was already here. I've got my opportunity set curve expected return and standard deviation that I calculated. All right. Now we did 13, 14. We don't have a lot to go, but let's, I'm going to cut this video and record a new one.